Okay, so we'll run a small example. Let's run a small example to see how this works. Yeah. To review the last chapter. If I have a mutable reference hello, and then I create a mutable variable hello, this is the owner of the data, and I create a mutable reference from that, then at the moment it seems like we have two variables, hello and a, two pointers with mutable access to the data. No? That's actually, and it compiles fine. So that looks a bit, doesn't make sense based on the rules we've learned. So so one thing it doesn't tell you is that you can't use hello anymore. Yeah. So if I try to, let's say if I try to append something to hello here, append string, and then passing something. So the method doesn't exist.
Push string.
Of course, push string.
Yeah.
Push string. Yes, yeah. Cannot borrow hello as mutable more than once at a time.
It's interesting that it doesn't break until you actually try to mutate it with it.
Yeah, I think it's because this is valid code.
Yeah,
this is valid code. So if we try, you can use a now.
Yeah,
that will work.
Because when the ownership stuff, that means it's invalid. Hello, and made a the new owner, right? Yeah.
Yeah.
It's not making a the owner. It's just allowing a to borrow it.
That's not
We borrow those. It is a borrow. It's ampersand mute, so that's borrowing.
No, because it's in the same scope.
Yeah, but this is borrow, right? Every time there is an ampersand.
I thought borrowing only.
It's not really borrowing. It's just you're making a reference, but the reference you're taking ownership of it.
Yeah.
No. This is borrow.
Because you can't use hello, so it's not a borrow.
It's not a borrow because the ownership's never returned to hello.
It is not in this case, but if I had, like, if you had a, I think if you had this.
Because it will never return to hello.
Yeah, it will never return, but that's just kind of a coincidence because.
Actually, that's a good thing to try. Can you try that? If you put hello with the.
Yeah, that will work.
Yeah.
Because then what happens is.
Oh, okay.
It only returns ownership when the reference got out of scope. So
yeah.
Here it just happens that both got out of scope at the same time. But now that there's a scope, A will go out of scope here, and hello will be valid again.
Oh, so that would be the borrow, yeah.
If my understanding is correct. Yeah, okay, so that works.
Okay.
That works. Right?
Yeah.
So basically when you are the owner and you give a reference to someone else, as the owner you become invalid until your reference goes out of scope, right?
Yeah.
Let's see what would happen if this was just a reading reference. Well, actually, I can still. It's going to take if I can still read. If I had a mutable reference, can I still read the original variable? Or is it completely unusable at the moment? I'm guessing I can, right? I don't know. Okay, of course not, because I have a mutable reference to it. So you can, it's pretty much unusable. But if this was immutable, then I should be able to, I think println takes an immutable reference as well. So I guess this would be fine. Yeah, that is okay. But this is actually mutable. So if I try to, yeah, I cannot mutate it. If I try to mutate it, it won't work. Yeah. I guess it's a bit confusing because you can see it's mutable here, but because you have a reference, then you cannot mutate anymore. Yeah. Okay. Let's move on to the next chapter. So slice type. Another data type that does not have ownership is the slice. Slices let you reference a contiguous sequence of elements in a collection rather than the whole collection. Here is a small programming problem. Write a function that takes a string and returns the first word it finds in that string. If the function doesn't find a space in the string, the whole string must be one word. So the entire string should be returned. Let's think about the signature of the function. So first word, so we pass a reference to a string. And what should we return? So I guess a slice. This function first word has a reference to a string as a parameter. We don't want ownership, so this is fine. But what should we return? We don't really have a way to talk about part of a string. However, we could return the index of the end of the word. Let's try that. So we pass in the string, we get it as bytes, and then, and by the way, for those who are not familiar, this returns, this iterates through the array, and it returns the index and the data, as opposed to just this enumerate function, as opposed to just the data. So then it's gonna check, and this is a bytes literal. So it's looping through every byte. If the byte is equal to a space, it returns the index. Otherwise, it returns like the length of the string. So the first word function that returns a byte index value into the string parameter. Because we need to go through the string element by element and check whether a value is a space, we'll convert our string to an array of bytes using as bytes. Next, we create, and this won't work with UTF-8, by the way. Next, we create an iterator over an array of bytes using the iter method. We'll discuss iterators in more detail in chapter 13. For now, know that iter is a method that returns each element in a collection, and that enumerate wraps the result of iter and returns each element as part of a tuple instead. The first element of the tuple returned from enumerate is the index, and the second element is a reference to that element. This is a bit more convenient than calculating the index ourselves. Because the enumerate method returns a tuple, we can use patterns to destruct that tuple, just like everywhere else in Rust. So in the for loop, we specify a pattern that has I for the index in the tuple and a reference to item for the single byte in the tuple. Because we get a reference to the element from iter enumerate, we can use the ampersand in the pattern. Inside the for loop, we search for the byte that represents the space by using the byte literal syntax. If we find a space, we return the position. Otherwise, we return the length of the string by using s.length. We now have a way to find out the index of the end of the first word in the string. But there is a problem. We are returning a usize on its own. but it's only a meaningful number in the context of the reference to the string. In other words, because it's a separate value from the string, there is no guarantee that it will still be valid in the future. Consider the program in listing 4.8 that uses the first word function from above. So it creates a string, hello world, passes a reference to first word, which returns the index, in this case 5, and then we call clear, which clears the string. Word still has the value 5 here, but there is no more string that we could meaningfully use the value 5 with. Word is now totally invalid. The program compiles without any errors and will also do so if we use word after calling sClear, because word isn't connected to the state of s at all. Word still contains the value 5. We could use the value 5 with the variable s to try to extract the first word out, but this would be a bug because the contents of s have changed since we saved 5 in Word. Having to worry about the index in Word getting out of sync with data in S is tedious and error-prone. Managing these indices is even more brittle if we write a second word function. Its signature would have to look like this. Okay, so you now need to return the index to the beginning and the index to the end of the word, since it doesn't start from the beginning. Now we're tracking a starting, an end, and an ending index. And we have even more values that were calculated from data in a particular state, but aren't tied to that state at all. We now have 3 unrelated variables floating around that need to be kept in sync. Luckily, Rust has a solution to this problem: string slices. So string slices. A string slice is a reference to part of a string, and it looks like this. So you have a string, and then you can create a slice from index 0 to index 5. That would be hello, or from 6 to 11. This is similar to taking a reference to the whole string, but with the extra bit. Rather than a reference to the entire string, it's a reference to a portion of the string. The start-end syntax is a range that begins at start and continues up to, but not including, end. If we wanted to include end, we can use. Okay, so I think so. Let's try an example. I think this is easier to understand with an example. So actually, we can do it here. So if I have hello as a string, I want to get the first word. So I will get like that would be in here, hello. So a reference from 0 to 5. 0, 1, 2, 3, 4, 5.
Which can you get like?
So can I get could I get a mutable? So if I were to do this, the same rules apply. So I cannot now mutate hello again, because I have, even though I don't have the whole string as a reference, I have a part of the string which is the same. So same rules. You have a reference to a string, you cannot mutate it. What I'm wondering is if I can get a mutable reference to that. I guess.
Just try and use that.
And
because I would also be curious if hello, if it stops you from using hello.
So
even though you've still got like 5 characters in hello that you don't have a reference to. So is it?
So according to the rules, if I create a mutable reference here, it means I cannot get an immutable reference of hello. So it's not going to allow me to use hello in any way. So if I try to print hello like we did before, this will not let me.
When you borrow, do you borrow the entire variable or just the parts that you're using?
So in this case, because it's a slice, we're just borrowing hello, so just a bit.
So you could still print out the rest of it.
No, because so basically, I have to think that hello is the owner of Hello World, and hello has now, well, A has now borrowed part of that. But there's no distinction if you borrow part or the whole. There's no distinction. Sorry, distinction. It's just Rust knows that you can read the data while someone else has access to that.
Yeah.
I can change it underneath you. So let's try it. If I try to run print hello, you cannot borrow hello as immutable because it is also borrowed as mutable. So can I push stuff into A? That's what I don't know.
What does it mean? Oh, I like it. Very good.
Can I push stuff into it? Anyone knows? I don't know. That would be
So no,
weird.
you can make it valid.
But that wouldn't even let you change something you don't want.
So just push through, even exists on a slice as opposed to a string.
Yeah, there's that too.
You can push to a string. Yeah, you're right.
I remember looking last time, I think there's only like 2 mutable methods,
Oh yeah,
and then they end up taking ownership.
yeah. No method push string found for that. So you can't. Basically, you cannot take a mutable slice. It doesn't make sense. You cannot use it, right? Is that what you're saying? Let's check the methods.
So does slice return a different type of string?
Yeah,
Oh, okay. Yeah.
that's more. That's
Yeah,
more.
like the quote.
It might be easier to see how this works if you use an array of numbers or something and took a slice out of that, because then you could change numbers in the middle of the slice
Right.
without having to do anything odd.
That's a good point. Create an array. Numbers.
As bytes mute is a mutable method on the slice, but it's unsafe.
That's unsafe.
Like if they say ownership and change it from if you don't own it, why they just stick to that? Like what's that? Why everyone-
So let's get the first two. Let's get the first two.
You don't own anything.
Data, whatever. And then what's the method for pushing?
Yeah, so I don't think you'd be able to push, but you could probably just say subdata 1 equals 10 or something.
Index
Set it
is
manually.
subdata.
Oh, okay.
Subdata square brackets. Set it to like 5 or 4. And you'd expect to come out with 5, 2, 3, 4, 5.
I'm going to say that would work.
Okay. Oh yeah. So let's
It's
do
more
this.
explicit, saying that you know it's going to happen.
So if we put this into its own thing.
Oh, and then try and print data.
And I can
Yeah.
I don't think it'll update data. It'll update some data, but not.
You think so?
We're using the explanation button on print line.
Oh, thanks. Oh yeah. That works. Yeah. So you
So
get.
if it wasn't numbers, if you had like, I don't know, some object. So like
Nice. So we try.
something, you would be able to, this is why this should be useful, I guess. Because otherwise there would be no point to get a mutable reference
Yeah.
of,
Yeah.
Slice.
Subdata ends up being mutable.
Yeah.
If you can't change anything in it.
Yeah.
I guess the only problem is because a
Yeah.
string you can't change,
Which then you're manipulating.
you can't change a letter in a string without
Okay.
being unsafe.
Because it's
Yeah.
data is just what you call it from what.
You can change the letter.
You can't take a string and then be like square brackets 0 and change it to the
Can you
letter
not?
B instead of the
Maybe you
letter
can.
Y.
Maybe you can. Yeah.
You can, but I'm assuming.
It gets complicated if there are any non-ASCII characters in there, because all strings and there's the Unicode.
Yeah, but I thought, but assuming it was all ASCII, I thought that would count as unsafe.
Well, you can only borrow.
So
I thought strings was supposed to be,
Okay. Or you give it to something else.
So is it just to
Well,
is it just to like limit if you're passing the data to a function? The point is, I guess, you're limiting the data that they're getting access to, right?
Yeah.
Because it's not like you can divide your data by 5 and passing to 5 different functions and in a mutable fashion. You can't do that anyway. But if they're reading, like if you were like rendering a screen, you can divide your bytes into 4 or 5.
return
And you would-
it's more that
So that's the thing I think
data
that's something I was just thinking about.
becomes
Like
a
what happens?
reference in
You
something.
could concurrently render the screen,
And then you manipulate the memory.
keeping all the bytes in
And
one
then you're
buffer,
dropping some
but
data
divided
memory.
by 5, 6,
You're not
and
returning
then
it, you just drop
concurrently
in the reference.
rendering noise
And
part.
then
I guess.
data.
Is there anything? I guess is there a way you can use like
Well, yeah, but
a
essentially,
string that's
if you can
hello
link
and
over
world
data as a
and just end up with a reference to hello and a reference to
items
world
of memory.
that you can just
You give
use it as a
0
however
to
you
2
want. It wouldn't really
as
do
a
that. It
reference.
wouldn't let you do that.
If it's not mutable, then yes.
Literally.
No, even if it is mutable,
Whatever.
it wouldn't let you do it because the moment you
Data.
try and create a reference of a second part of this.
But you can have a
same
This is
string,
data then
it would
you
be
use
like
yourself.
saying you're trying to take ownership, you're trying to borrow something that's been borrowed.
No, but
I think so like the actual provides a split out new method which uses unsafely determined intent
To do that.
So that you can go, because they know that it's okay because you've already
Basically,
it's okay, so it's used unsafe inside them.
But on line 8, you are writing to the memory from a different range. You're given a tiny little chunk of memory, and you manipulate it.
can you not push into
And then
arrays?
you drop in that, like reference.
No.
Return values if you don't know.
You can.
Mindset, then what you like.
It just doesn't grow. It's just
You
yeah,
can do
it's
that.
constant size. Yeah.
Yeah,
Reference.
do vector.
And then the pointer is just
Yeah, but then when you borrow it, you get an array. So that's how it protects you.
Yeah.
All right. Yeah.
And you can get
So it's very secure anyway. Yeah. You can mess the data.
Technically, you can pass a whole. You can pass the whole vector in, but you usually, even if you're passing in the whole vector, you pass a slice of
An array, yeah.
of the an array of the whole vector.
and drop the data, or parts of the data. And then by the time the data tries to use it again, you better read someone else. Just really like where all this security goes.
Right. So it's
To be honest, that's what I'm saying.
Yeah. Yeah, but that's like the advantage of Rust is that they've given you a syntax that looks very, very similar.
you're right then.
Yeah. Yeah. Like more like I think myself like yeah, wow. Okay, cool.
In a good way or
Memory rather than
Remember,
return types.
okay? So
what
what?
you said at the core is the memory.
Right. So similar. This is similar to taking a reference to the whole string, but with an. Oh, sorry. I read this already. Yeah. The syntax is a range that begins. Yeah. If we wanted to include end, we could use this syntax instead of that. Okay. So this just includes the character at index 4, whereas if you don't put this, it goes up to 3. So the equals means that we're including the last number. If that helps you remember the difference between double dot or double dot equals. We can create slices using a range within brackets by specifying starting index, dot dot, ending index. Where starting index is the first position. Okay, we've already done this. Okay, this is interesting. So internally, the slice data structure stores the starting position and the length of the slice, which corresponds to ending index minus starting index. So in the case of let world slice from 6 to 11, world would be a slice that contains a pointer to the 7th byte of S and a length value of 5. So we got the same data, just a different pointer. Very efficient. It just points to an address in memory and has the length,
Two variables there.
so it knows how to move forward. And just remember that this data cannot change, so this is completely safe to use this pointer, because otherwise it won't let you compare if this data was not correct. So, which is a simple thing, but that's the essence of Rust. If you compare it with C or other languages, if you have a pointer, you really don't know if the data is still correct or not. You have no guarantee. This is good. With Rust .range syntax, if you want to start at the first index, you can drop the value before the 2 periods. So this is just syntax sugar. You can leave out the first number and it will start from the beginning. And equally, you can leave out the last number and it will go until the end. So this is equal to this basically, but less messy. You can also drop both values and it will just get the whole thing. I don't know why you would want to do that, but who knows. String slice range indices must occur at valid UTF-8 character boundaries. If you attempt to create a string slice in the middle of a multi-byte character, your program will exit with an error. For the purposes of introducing string slices, we are assuming ASCII only in this section. More through discussion of UTF-8 handling is in the string section of chapter 8. With all this information in mind, let's rewrite first word to return a slice. Right, so let's try to just do it ourselves. Function first word. So S is a string. It's actually a reference to a string because we don't want to take ownership. And then that's it. And we return a slice, right? Yeah, a slice. So what would that look like in here? Would it be like that? Yeah, just like that. So I think it was doing that. Let's ask bytes. And then if right, so if it's a space, then we can return a slice of S. And we go from the beginning.
0 to I.
So I don't need 0, right?
Oh, can you admit that?
Like that.
Okay.
Yeah, so you can omit that if, like they were saying here, this is equal. Both are the same.
Oh, okay. Yeah.
So that's it. And then if not, we just return the whole slice like that. Can I omit? Does anyone know if I can omit this? Can I do that?
Yes.
Same.
Yeah.
Yeah.
That should be the same.
I
Right?
don't think that'll work because it's a return from the function that will return it from the if state.
Oh, that's returning from the if, right? So we could catch it, or if we don't do anything, it just be lost. Is it?
I think so, yes.
Okay, let's try it anyway. I've seen this failing before, and I was wondering, well, yeah, that's why. So now let's get some string. Hello world. And I always choose the same string.
Oh, you have to do ampersand hello.
Yeah.
Ampersand data set.
Okay, so it's allowing you which
So this is
return or not.
Do I need to return? Maybe. Let's see. Yeah.
Oh,
Yeah.
okay. Is that because it's in a block then?
I think it's because, yeah, so when you omit the semicolon, it returns from the current scope. So this is on this scope, but this is inside the if scope. So I reckon I could do this. And then I could do that, maybe.
So you probably need to have an else for us to do that though. Otherwise, what would it assign C to?
If I do this, then I can just return, yeah, but I still have to return. So
The problem is if car is not equal to B, then what would C get assigned to?
well, that will fail, right? Compilation. Oh, whoa. Yeah. Yeah, that's,
Although it says
I guess
you
we
could
just
have
have
put a
to.
semicolon. If it was. So if you had put a semicolon at the end of the if.
At the end of the if, oh yeah, here,
Put a
yeah?
semicolon there.
Yeah, you're right.
So what would it be if it wasn't? I guess we would know because it.
Oh, but I don't actually want to return here, yeah. Because otherwise it's just stopping.
If maybe missing an else clause instead.
Yeah.
What's missing?
Oh, it's complaining that C could be null.
Yeah, I think,
Because if it's not equal to an empty space, C is going to be a null value.
yeah, I think,
So therefore you're returning null.
so here I think that's it. This is it, no? That's how you have to.
Unless you return else.
Oh, then why would I do inside the else? I can't just.
I said, yeah.
Can you put a continue in the else? I think you can because then it returns another. And
Hang on a minute. All right, so. No, but they have to match, no? What they.
no, because then returns another time and that then doesn't need to match.
So we continue here, or this. It returns that.
Do you still not need a semicolon at the end after you put the left?
Ah, yeah, sorry. Here? Yeah.
Yeah.
I think so.
Let's call it R4 short.
Yeah.
This is just overcomplicating it for no reason. We are saving. This is already not worth it because we were supposed to save return, but now we have else continue.
Have a return. Do anything.
It was sorted before.
You're not handling the
Doesn't matter much.
No, I mean, it's gonna work. Like it's not gonna return anything.
But what?
You're making my life really difficult right now.
yeah.
Oh yeah, that works. Well, no, that didn't work actually.
No, because it should return hello.
Yeah, because you're not handling on.
Yeah, because you're passing still returning the whole.
Oh, you never return R.
Yeah.
So I return here. Yeah, I can return here. And yeah. So when it goes in here, it will
Oh,
go
yeah.
in here.
Yeah.
So I will return here. But I still have to put the return arc, so there's no point. Right?
Just because.
Or can I put just arc?
Well, yeah, and then you're gonna have to restructure the for loop. Can you do let something from a for loop?
Yeah, I think you can. Yeah. So you can move. You can saddle the arc like that.
Oh, come on.
This has been absolutely butchered.
Then when you open a code review, your colleague's gonna kill you when they see this code.
Looking at the merge.
Or what if it never finds a space? Then what's gonna happen? If
Going
it,
on a rabbit hole of nickel.
so if it never finds a space, this is gonna fail. This is gonna fail because it might return a slice or it might return nothing. So it's not
Yeah,
gonna
half would still
it's
be
not
wrong.
gonna let you compare at this point.
Yeah.
Unless we check if we're in the last index and then we return the whole thing. But yeah. Yeah, forget about it.
Yeah, but you don't put something colon.
Yeah, why is it working?
Unfolding.
Oh yeah, yeah.
You need a semicolon and folding.
Also, copy this, snip it into
Where
the
else?
On line 23, you need
Yeah,
a semicolon.
online.
23. That's why it's complaining.
Is it not gonna complain?
But it's still going to complain about what?
Yeah.
25, is it?
DS. Or
Well, she's going to complain about the return type.
Yeah.
Yeah, here. Anyway,
copy and paste this into
No, I feel
the
like
the
I'm
chat.
trying to get this to work. It could be worth it.
Yeah, but you've got 27 and 25 that you're trying to return. You
dude,
can't-
let's just park this for a bit. We can finish it later.
Anyway,
Yeah,
that return
it's
thing, continue thing I've done before. Like, closely.
We can cut this part later. Okay, so that's all good. So with all this information in mind, yeah, we've already done this. Okay, so now when we call first word, we get back a single value that is tied to the underlying data. The value is made up of a reference to the starting point of the slice and the number of elements in the slice. Returning a slice would also work for a second word function. Yeah, we now have a straightforward API that's much harder to mess up because the compiler will ensure the reference into the string remain valid. Remember that bug in the program in listing 4.8 when we got the index to the end of the first word, but then cleared the string so our index was invalid. That code was logically incorrect, but didn't show any immediate errors. The problem would show up later if we kept trying to use the first word index with the emptied string. Slices make this bug impossible and let us know we have a problem with our code much sooner. Using the slice version of first word will throw a compile time error. So we're getting a string, we get a reference to that string, therefore we can't change the data. So word will always be valid, it's guaranteed by the compiler. It just tells you immutable borrow occurs here. And if you try to clear it, that's a mutation. You can't mutate it because someone has a immutable borrow. recall from the borrowing rules that if we have an immutable reference to something, we cannot also take the mutable reference because clear needs to truncate the string. It tries to take a mutable reference, which fails. So not only has Rust made our API easier to use, but it has also eliminated an entire class of errors at compile time. And
So does setting word to something completely different entirely like free up the borrow? Like you can,
like shadowing it?
yeah, maybe.
Yeah,
You can't.
Well,
do
you
that.
can mutate it. You can mute.
No,
you
but
cannot
shadow
mutate.
it.
You
You can shadow it. Yeah, that's fine.
And that becomes like the example of sense.
Let's give it a go.
Yeah, it does. Yeah, I feel like I've said it before.
Don't delete the example. No, don't do
Yeah,
it.
that was a really good example.
Yeah, copy and paste that into the Slack channel.
Whoever makes it work, man.
Probably like,
Bring it tomorrow.
so that's like, what?
No, I actually need to delete it, man.
Comment it.
Okay.
Yeah, comment out.
That's the beauty.
We didn't get really good coding.
Right, now I have to redo the proper version of this. So we make it work.
No.
No.
Right. Right, so we get a string, we get the first word, and you were saying if we just shadow s with something else.
I was thinking shadow word
Shadow word?
because S will error.
Oh, okay, yeah, okay, I get you. So now word is invalid, therefore it should let us call clear, right?
Yes.
We might used to use like the nightly, no, again, I guess.
Well, hello.
Let's try this.
Semicolon.
Yeah, you need to.
Oh, sorry, this crap again. No, I cut it. Immutable borrow occurs up there.
Yeah, let's go to it.
Yeah, so it hasn't.
They didn't give it back.
When you do this,
Just by
it doesn't drop words. It just statically.
That's interesting.
so in some sense that is a
It is still there.
dangling reference. The reference is not there, but the compiler still can.
But the data is there. The data is there. If you could use the reference, the data would be there.
Yeah, but it's not an issue because you can't use it.
I suspect this is the one that might compile it, enable the experimental non-lexical nice times.
Yeah.
Yeah, that's what I was thinking. Yeah. So if we do the same as before, well, actually, yeah. So we need to do that. Feature.
Exclamation mark was it?
I think it's hash exclamation mark open square brackets feature.
Yeah.
I have to look at.
That's very precise. That's very precise.
Rounded brackets, is it?
Yeah.
Tiny.
Yeah.
NLL.
Right here, right?
Yeah.
LS.
No,
No,
And then LL.
L.
N LL. Yeah.
yeah. So,
Right, okay, so
wow. So okay, so it's getting better. Does anyone know how this actually works? Or Or what are the changes in the new? How does this work? And it doesn't work before.
So it recognizes that it drops. Right? Like out.
So it keeps track of that, whereas before it just doesn't. So if we're creating word here, and then here we kind of make it invalid, and the new compiler takes a note of that kind of thing, and it assumes that word was never created or it has gone out of scope, kind of thing.
I think it basically recognizes that the first word on 6
This one.
is no longer used. Like on line 9, for example. So
Okay.
obviously there's ways of copying that again into another variable and then put it, like trying to use it on line 9, but it knows that you haven't done that.
It knows that you want to reference the second. Makes sense.
Oh, so we can create another. We can try to trick here, no? We create another variable.
Yeah.
Which has a reference to word. So now another and word both have a pointer to s. But that should fail, right?
That's fine again, I think.
Yeah.
Another will still work.
It shouldn't let you clear s
Try use another after word.
because you have another, right?
So if you try and use
Another.
another on line 10,
Yeah.
Try
then
to-
it won't let you do this.
It should fail.
So it knows that I haven't used it. That's why it lets me compile.
Yeah.
But it doesn't make sense, I think.
No, that still works.
It doesn't make sense because
That's interesting.
S clear takes a mutable reference to S. But at the same time, I have another, which is an immutable reference to S as well. So that should straight fail. But it doesn't. So
That's it, you're not doing it, you have to do it after line 14.
yeah, but you know what I mean? Like another is now a valid reference in the scope to some data. And when I call this function, Rust is letting me borrow it mutably. So I have an immutable borrow, another.
Well, it's not necessarily invalid, is it?
But you're not trying to use another after 13, are you?
But it doesn't matter. Like if I try to do this, it will fail, right? Even if I'm not.
I think that's the point. There's a now or word.
That's the thing. You don't need to use it. It should be
Oh, yeah,
it's
it's
strict
saying
enough.
it's not because it's not declared as mutable.
Okay, let's see. So if I
Yeah,
try
so-
to use another here,
If you declare word as mutable.
do you think this will fail?
Yes.
So that will just print empty, was it?
No, it won't work.
Cannot borrow S as mutable. Oh, okay. I think I know what's going on. So this compiles fine in this case. But I bet if I change to stable, it will not compile.
Yeah.
Oh, yeah, definitely.
Maybe it's just because now it's clever and it actually knows if you're using it or not.
Yeah.
So it's gonna be much easier to use Rust kind of thing. Because you don't have
Yes.
to think about it.
And
But it's not just going to fail because we're not using it. It's going to fail because Word was shadowed.
Yeah, so it doesn't have that feature work.
Yeah. So it's just the new thing. Make sense?
yeah.
Cool. Wow, so it's gonna change a lot, the new version. Like it's not gonna complain nearly as much. I don't know if that's a good thing or not. I
Yeah.
think it's a bad thing. Then you can have immutable references and mutable reference in the same function, and it's not gonna say anything until you try to use them. Because someone looking at the code, if you see the two variables, you assume, okay, I can use them.
So it's still safe, right?
No, it's still safe. Yeah,
Interesting.
interesting.
Very interesting.
Interesting one. Well, okay, up to here today. Let's see. Unless anything else you guys want to discuss, or
Back to the example.
Well,
How much left is there?
Sorry?
How much is actually left in the chapter?
Oh, sorry, it's not finished. No, sorry, it's not finished.
Although it doesn't seem like that.
Okay.
So you're trying to get out of reading.
String slices as parameters. You can take a second. Okay, so a more experienced, let's just finish chapter. A more experienced illustration will write the following line instead because it allows us to use the same function on both string and reference to string. So if we take a reference to a string, you can pass both. If you take a string, you can only pass string, so it limits you.
Oh, does string inherit from the slice string?
No, but you can explicitly slice it to be all of it.
So it does
Oh,
actually
right.
also convert into a slice as well.
No, it doesn't. Oh, it does.
It's influenced something called the deref trait, which I think is correct.
Oh.
Many chapters further on.
Yeah, so I think that's the reason why you can call dot something on a reference, isn't it? You can call dot if you have a reference. You can call dot
Instead of dereferencing
because
it.
it uses the references for you. At that point, I think.
But I would have thought it wouldn't implicitly convert from string to string.
I don't think it does that. Or
It's
maybe it's,
that
a,
would be,
maybe it's a new thing.
I think it does, doesn't it?
So let's see.
Because you pass in, you always pass in like a slice or something.
I'm gonna do a very.
It could just force you to put square brackets, 2 dots, and like, oh, I just want to slice the text from the beginning to the end instead of implicitly converting it.
If I just do that.
Way, I guess.
I suppose they just decided it was too annoying because it strings around so frequently.
It doesn't matter what it says. It doesn't matter. So we have a string and a reference to a string, or a string slice. If I declare the function saying this accepts a string, according to the book, I'm limiting it, so I can only call it like that. I cannot call this with st. That just won't work. I mean, it makes sense, right? Because st is not a thing you can grow. So, and this is taking ownership. So all of a sudden here you would be able to grow it, to push to it and stuff. So that fails. On line 6, you can pass st here. There is no way you can pass st unless you could do this, right?
There's also st.toString apparently.
Yeah, so you could do that, but it's a bit verbose. Yeah, I think that's what they're trying to get at. It's a bit verbose. So if I declare my function saying this accepts that,
You do it print line with that kind of string.
this one,
Yeah.
yes, yeah. So that's why so I guess what the println does is the reference. It converts the string to a string slice automatically, right? I'm guessing.
I think it's at the console.
So what you were saying before is that if I pass as st here, I don't need to pass it like this. Is this correct? Do we think that if I pass it like this,
Oh, you still need to pass in.
well, I mean,
Yeah.
no, sorry, I mean this one. I need to pass it like that or not?
Well, you need to also add square brackets.
I don't think you do need to script. I think it will work like that.
Yeah.
No, so
Ah,
I think if
that's
we,
what you're saying about implicit.
It works like that.
yeah, so if I do that,
But the second one needs changing, doesn't it?
Huh?
It should fit on both lines because the second line still needs a reference.
so I'm passing, yeah, so it doesn't do it, but it doesn't do it automatically. It's saying you're passing me a
Yes.
string and I'm expecting a slice.
Yeah.
So
A slice reference.
But it says
If
consider
you just write
borrow.
ampersand s, then it will work. I think.
yeah, it's a borrow. So I need to
Yeah, because at the moment, print string was moving it.
island it here.
But now
So that should work. You can transform a string to a string slice by doing that. And I think this is exactly the same as doing this, by the way.
Oh, okay.
Wait,
So it's taking a slice of the whole thing
why do you not have to add the ampersand in front of ST?
because it's already this. By the way, this. So what happens is this is the same as this.
Oh, so the type of ST is.
So Rust
right.
inherits the type. Yeah, basically this is the same as writing this.
Oh, okay.
Okay.
That's why you sometimes you will have to write this as well. But this is smart enough to know that that's why you are.
Yeah, see, that's the part that confused me. I thought the type was just str, not
Yeah.
reference to str.
Yeah.
Because a string created a type of string, not reference. To
No,
string.
so
it's
str doesn't exist as a type. It needs to be like that, and they're not mutable. They can never be mutable, or they shouldn't be
And you
mutable.
can pass around.
I mean, you can
and
do
you can
unsafe
pass
code
around
and
Owen strips as well.
you can do what?
assuming they can be mutable.
They can be mutable,
It
right?
can be mutable, and you can pass around Owen STRs without the reference.
Okay, you have to solve it sometimes. Then.
It's mutable
Well,
in
you
the
get
sense
rid
that
of
you
the
can set the boundaries.
And then add an ampersand at the bottom, I think, will behave the same. Yeah, so
Hang on a minute. So I,
ampersand on line 6.
Yeah.
And then change the line 3 signature to be just STR.
It will complain about the literal not having a compatible type of the variable.
and I'm guessing I have to. Okay, so is that possible? Can you do that?
So let's try it.
I don't know.
Magic.
Magic.
It should complain about the types.
I was gonna say, because I assume that that's not a constructor. Like, you're not constructing a string there, right? You're just having. Yeah.
But it implies that str is a type. It doesn't say str doesn't exist as a type.
It's definitely a type, but
So there must be a way to
try
create
again
it.
on that one.
Yeah, I don't know how you construct that.
Do you get them from strings then instead?
You do new string. Is that a thing in Rust?
You just do the
Oh,
thing.
We can do string : : new, but
But it doesn't. If we look at the documentation, it doesn't have that method.
There is an entire chapter later on about strings.
yeah, scroll on. Scroll.
Here.
Oh, see also this str prototype.
It's also called string slice, right? So
Oh, look,
it has to be. It has to be a reference.
It's usually seen in the borrowed form and str, but it's not always.
We'll look at that and see if
Tempting. It has a lot of methods.
can you label your main function
So I
to
think
see
you can't do like, you have a string called hello. Well, not the string itself called hello, but your variable called hello. That is a string. You can't have hello square brackets ... 5 without the ampersand. You have to have the ampersand to get a slice out of it. If you, because I'm thinking, what if they had it so that if you didn't put the ampersand,
Then you take ownership
then you take ownership of just
of just
part,
that.
and then the rest just gets cleared out or whatever.
I would think that's not possible, but
It would be weird behavior.
Yeah,
because
I don't know
then who drops that? Then no one will drop the whole thing. When your slice gets out of scope, it will only drop
Just the
the
slice.
subset.
So you would essentially, by doing that, by being able to do variable name of square brackets ... 5, you're able to essentially say, I want the first 5 and delete everything else. I literally delete, just drop everything else. It doesn't exist anymore. I don't care. I just want the first 5. And you own the first 5.
So I would say
and
in this,
never
right?
get access to the rest again.
I would say in just doing that.
That's what I'm thinking is that thing in the language.
I haven't seen it. Let's see. No, I don't think it would be one. Let's see.
This is the chapter answer exactly ends by saying, to summarize, strings are complicated, let's switch to something a bit less complex, hash maps.
consider borrowing here. So the size for values of type str cannot be known at compile time. Okay. Right. So he actually doesn't know how big it is.
Yeah, which is why you need a point.
This is why it needs to. You can't take ownership of something that you don't know how big it is.
So because that's dynamically creating a string,
Can you put it in a box?
Come
Can you box new?
Are you serious? Come here, do it yourself.
I can't type on your keyboard. Can you just put box new around that? Yeah.
A box is just basically a pointer. It basically tells Rust, store this on the heap, right? And only care about the box.
Yeah.
Therefore, you always know the size of the box because it's always a pointer. It's complaining about not knowing the size at compile time. So you usually put a box when that happens. No,
So it still needs to know.
it's not known. You can, so I will put the traits. I will put size trait.
Oh, yeah, the engineer.
So I suppose when you're passing something into the box constructor, it has to go onto the stack first so that the box can then take it off the stack and put it on the heap. So if it doesn't know the size, you can't even pass it into the box new.
No, but usually you can pass, right? Futures and stuff too.
That's in the box. No?
But the vec is a structure of known size that points to something of unknown size.
No, but you don't know at compile time the size of vec.
You don't know how big the bits on the heap is, but you do know that there's a structure of fixed size that contains the pointer to that.
Right, whereas this doesn't have a size at all.
Yeah.
Point of capacity size.
I think you just have to do that and get a reference.
Well, we cannot get that in this rabbit hole, but hey.
Yeah.
asking the real question is, can you put a box inside a box?
Oh, yep,
Yeah.
that's very important.
Yes, you can.
Why not?
Yeah.
I mean,
Just keep going.
A box inside a box inside a box.
Yeah.
Isn't that just like Nicholas? With like pointer to pointer.
Yeah, so
Yeah, I
that's,
guess so, actually. Yeah.
that's how they do recursive lists, yeah. Yeah, so if you had an enum, I think they do this. Well, yeah, so you have an enum, and you can have, let's say it has a string, and then you can have another enum of the same type, right? So it's like a recursive, it never ends basically. This one, right? This one never ends. So let's say you could have, maybe you can have none here. It has a string or nothing, and then it takes A. That should just fail, I think. No, that's okay.
What are you trying to do?
So I want to create a list of like A, right? So I will do A.
Should I? Wouldn't work.
Oh, sorry. Yeah, that's not right. That's
You want it to be.
so next will be of type A. Isn't it?
I do.
No, this is easy. You can take a name.
I've not touched boxes.
So the enum can be a string or none or itself, right? That's what I want to do.
These are all named things in your enum. Are you trying to make a string enum?
How do I say my enum contains?
Yeah, rounded brackets. So if you do A open brace, B rounded brace with a string inside of it.
Oh, okay. Yeah, you're right. Like that, right?
Yeah. So the variant owns a string.
So
Yeah. So it has. Let's just call it data. It has some data, or I want to say or it has a link to A, right? Is that okay? I think that's.
Yeah.
Yeah, and let's say the data. Let's say this is an option because no, this is an option. whether it has an A or nothing. So then nothing will be the end of the list.
Why don't we just have a none?
Sorry, the option will have a none, right?
Sure. Right.
So like this. So I'm trying to say, this is not, you don't know how big this is. In memory, you cannot know because you can have infinite A. So if I just create this, the link, and it contains another A, right? With no, actually, I'm getting confused.
Then inside that, you create an A with data. I guess.
Yeah, with
definitely.
With like, I don't know, hello and
Yeah, for the easiest to do data first, then.
yeah, but the problem is I want data and I want the link as well, right?
Yeah, that's right so far, isn't it?
Yeah, but it's not a link, is it?
Oh,
Oh, I see you put another,
Because I had to create a link.
a link and a link, and a link and a link.
Let's say what happens to this. I wanted to get to complain that it doesn't know the size. That's what it does. Yeah, recursive has infinite size, so it doesn't know how big it is, right?
You know,
wait, why? I don't understand.
Well, because I mean, possibility, you can have. It's not smart enough to know. It just says, okay, you have a type. You're declaring a type here, but how much space do I need to allocate for this? Because if this was mutable, I could keep adding to this. No, I could keep adding and adding and adding. And
Yeah.
it doesn't know how big it's gonna go, so it doesn't know, I guess, how. It doesn't know how many space to allocate for that list.
wrap the
So
option
then,
in a box as well.
yeah, so that's what I wanted to say. So once you have something like this, because you don't know how much it's gonna take, then you can do this. It's a box, and you immediately know that when you are gonna allocate memory for this enum, you will allocate memory for a string and a box. You don't care about A. So
And box is just a pointer to.
yeah. So now it has a size. Now it can compile.
Why doesn't option has a size? Like, isn't option like optional? Isn't that what you mean by it?
Hang on a minute.
You need to box the data.
Why?
Box the link. So A : link box new
Oh yeah, box. Yeah, now needs to be a box.
box :
Colon new.
You need some in there as well, so it's an option.
You need to put rest.
Is it?
So does everything in Rust have to be a fixed size? No, no, compile time.
No, only for the it's only if we're trying to like even in any other language, if you were trying to define a type where the definition of a type used the type itself, then you try to create an instance of it, it would still complain because it doesn't know how much to allocate in terms of memory. Because every time it tries to figure out, it goes and finds it has to find the size of itself, which it doesn't know because it's trying to figure out the size of itself. So by wrapping it in a box, you're saying, I just want a pointer to
Yeah. So
A, but all pointers to everything have the same size. Is that correct? But my question is, why doesn't option have a size? Because surely option in and of itself should be a definite size, but then you either have something inside it or nothing, and it is the one that tells you whether it has something inside it or not. So like, I don't know, a possible implementation of option is just something with a pointer inside it, and the pointer either points to some data or doesn't point to anything.
Yes, this is what we've got here, is if you want a pointer, you can write it explicitly, like we just done. If you don't need it to be a pointer, then it isn't a pointer, so it's a transfer.
So this will go, Rats will go, so list variable has, I'm gonna allocate memory for a string and an option of box. So if box is, I don't know, 5 bytes and string is just a pointer as well. So if it's 5 and 5, so that's 10. So it knows I'm gonna allocate 10 bytes for list. Because box, it will just be a pointer that it can follow through to something else. But if you have it like that, then that becomes recursive. It will go, oh, okay, so I'm gonna give it 5 for string, but for A, I'm gonna give it, and it will go 5 for a string, and then it will just continue looping, so it won't know how big it's gonna be because it doesn't know how many A's are there, right?
So what's an option? Is an option a
An
pointer?
option is an enum. It's just an enum declaring the standard library, which allows you to say some.
Whatever.
It's generic, so any type is just a wrapper to say some or no.
Oh, right. So it's like the maybe monad.
Yeah,
Yeah. Okay.
it's like a nullable type. Yeah. But anyway, just wanted to because I know this example of box when it's used, this kind of thing. So another example I've seen it is when you call an API and you get some data, and then that's a future, and you want your function to return the future. Rust goes, well, I don't know how much data is going to come from that API, so I don't know how big the future is. Then you just put a box, and it just doesn't complain anymore. Yeah.
Okay.
Put it in a box and it can't complain anymore.
Huh?
Put it in a box and it can't complain anymore.
Well, it can complain because you will know you will do something like my function. I don't know, API call returns. It basically returns a box of, and then this will be a future, I guess. How can you know more about functions, about future? I think, can you say the future that is going to return something? Yeah, it's just like this, right? You can say the future returns a string at the end of the day or something like that. I don't know the syntax, but oh yeah,
Yeah, it's
like that.
Yeah.
So you will say it's a box of a future of a string. So then Rust doesn't complain, and then when you call this method somewhere in your code, you can do API call, and whatever you get back, in this case, is a future. That's on the heap, so you can just do, I don't know, get the result or whatever, and because it's typed here, you know that you're gonna get a string.
You have to get rid of the box first. Or does
And that's
it-
the reference. It does it for you. So you can just treat box as if it wasn't there in the first place. When you hit the dot, it's gonna dereference it for
So
you.
that's the same as the ampersand string that we saw earlier, the deref trait, makes it a transparent type of the
Yeah.
Do we leave it then?
Yeah. Okay.
That just reminds me of promises in JavaScript.